We're going to open up this bad boy again. We're going to look at it more thoroughly. We're going to take some resistance readings, make sure we don't have any opens in this coil, and then we're going to hook it up to the mighty 1650 impedance bridge. If things are still connected, we're going to see how many henries of inductance or microhenries of inductance there are in this coil to get a feel for what's going on in here. We have three wires connecting. They're the red, black, and unshielded. It goes to green, yellow, and black. So we have to see how they're made up here in this coil. The coil doesn't look too hot. The initial readings look promising. All the values I have to subtract 0.8 ohms because that's the resistance in the cables themselves. But just looking at this, red to black shows 1.6 ohms, and then black to unshielded shows 1.2, and red to unshielded shows 1.2. It looks like the unshielded is the center tap. That's obviously not an exact measurement. We're going to put it on the impedance bridge and see what we really got. Just to make sure machine is operating correctly, we show that these gold-plated banana jack and connectors that I use here are showing 0.7 micro-ohms of resistance. I'm not really concerned about the resistance values at that level. So we'll consider it a null, and I will set up our device here for some resistance readings. I got black to red connected right here, seeing 0.96 ohms. Right there, 0.96. Now we're set up black to shield. Black to shield, I'm seeing 0.62. 0.62 black to shield. Red to shield, almost identical, like 0.625, so it's like 0.62 is the same. Now that we got that, we're going to look at inductance. We're going to switch this over, and we're going to see what the amount of henries are in this coil from end to end and through the center taps as well. I'm going to assume low Q and start with micro henries and see what I get. Not knowing what this coil is, I'm not really worried about the Q on this, but eventually I'm going to be able to tune it in and see what we got. Turns out it was the high Q setting after all. What I got to tune this coil, black to red, turned out to be 4.1 microhenries with a Q of 4.4. So that's what I got. I'm going to double check this, obviously, make sure there's not a false dip, but that's what the reading is. So I'm going to check that again, and then black to shield and red to shield and see what I get. This would have been different from red to shield, but it reads 4.05. And I've tested and retested this for red to shield, which is almost exactly the same as red to black. So that's the reading. Q is the same. So I'm going to read black to shield now. And black to shield shows 4.1 microhenries and Q shows 4.6. The last test, of course, is to null it out, make sure the field collapses, and we see that if a short is displayed, it's no good. We can see that a short displayed destroys the test, so there is a field. That's good. So I'm going to give an update of some discoveries that I made. If I had gone through step by step here, I would have really bored a lot of people, but this is somewhat important. And remember, I don't have a book or anything about this unit, so this is found by trial and error. As most people would know about these units, there's a capacitive and an inductive pickup on these systems. Primarily what we've been using is the capacitive right here for the primary. And as it would turn out, at least anyway capacitive, it was thought that picking it up on the secondary after the fact seemed logical that this would be the secondary one. And we've been measuring it for how many henries it was earlier as inductive. What wasn't readily apparent was the fact that it was inductive probably meant that it wasn't being used for any of this at all, right? But it was shortly after I started doing these tests that I started to question this and say, why would we be using this for the secondary if it's inductive? So I started doing a little bit of research, and I started doing some tests. And what I did was I started testing this, connecting and disconnecting this from the primary while the primary test was going, and saw absolutely no effect that this thing had, which obviously was expected if we thought that it didn't work in the first place. And I had replaced the amplifier on the circuit board that I had suspected to be bad. I still have the old one. If it's still good, it's not a problem. I had discovered that if I connect and disconnect this thing, I saw nothing, not a blip, not garbage on the screen, absolutely nothing. And I said to myself, there's a strong possibility that this connection here has absolutely nothing to do with the first 4 options on this unit. And I said, well, if that's the case, well, what does it do? And it didn't take long to figure out that it is in support of options 5 and 6. What I found is that in setting up this unit for 5 and 6, this connector here has a direct effect on the alternator electronic ignition test as well as auxiliary. And though I haven't set up for this unit, I did see that disconnecting immediately removed the pulse from those 2 settings. That showed, number 1, that they are used for those options 5 and 6, and number 2, that the pickup works. So there's not a problem with this pickup. So it's back into the unit to find out why the circuit for 3 and 4, the secondary, does not work. So at least I'm no longer chasing something that isn't a problem. I want to show you what I got on secondary parade. I dropped it down to 2 cylinders only so it'll draw better on the screen. And this is only when I kick it up to 60 HGI, so we can see some sort of pattern here. If I drop it to 60 or 30, 60 is barely noticeable, and there's 30. We can see a little tiny speck. So we are seeing something, but it is attenuated considerably. When Jason gave the gas before, we were able to see that it responded with the speed of the engine, so we know that that's good. I have gone and swapped some of the op amps. I've Easter egged them out to see if any of them were failing, and they were not. They've all been replaced with new ones. I'll put the old ones back in later, but I wanted to see if that would be a quick fix. But now I'm going to have to go and trace out and see at what point this circuit deviates and how we could find out exactly what's going on here, what's wrong with this. I've pinned out the conductive clamp, and now I'm going to find out where it comes in. It definitely doesn't come in on the same circuit board, which was the sync board, as the inductive clamp. So I'm going to have to trace this one back. Yeah, so no doubt I'm not going to be able to trace pins all the way back to these cards, because it looks like the signals immediately terminate into these amplifiers down here. Point out that while there are 3 wires, 3, 8, and 13, we come to find that on the connector 8 and 13 are common as they are soldered together. So what we're really looking at is 3 and 8. Input's going to be here, Z1101. It's going to come out pin 6 because it has to. 6 jumps to pin 2 to R1103, here to R1106. Comes off R1106 into this trace right here. We can see the trace is the second one over on this ribbon cable from the right, just under the number 2. So I'm going to check with a connection from R1106 onto this backplane here and see where it's connecting to on the circuit board. Sure enough, one side connected, we come up on this board here, the sync board. And there's our input signal right there. It's got to record what pin number that is. Sure enough, sync board number 400, pin 13. So we're back to the same board again. There it is right there. Let's take it out, have a look. Now we know that this portion's all good because the primary's working just fine. And it's the same signal that runs through here for primary and secondary. There's no need to be in here any further. There's no more work to be done that I know of. Other than that, I've replaced the amplifiers here, which are good. And the old amplifiers are probably good too. I'll probably go and put the old ones in if need be. But yeah, so I'm going to close this portion up now. Besides, it's really dangerous to run this portion open. I have to insulate everything. So after taking the bottom of the unit apart, I find that this kilovolt selector switch makes its way via ribbon cable all the way to the back to this ribbon cable on the right. And that in turn goes to one of these 3 calibrated potentiometers. And you can see here that this is how they are calibrated. and it goes in and out of this. I haven't yet figured out where it goes from here, but I know that the signal does right through here. Scope right to that pin 2 connection to see if the attenuation happens right up here in front. I wasn't able to get any meaningful data off of that pin directly. I'm gonna have to trace it out. That pin 13, but after there's 2 capacitors, I imagine they provide some decoupling as well as some filtration. So I've got it connected after those 2 capacitors, and we'll see what we got. So here's what I'm seeing, and I know this works, because this works for primary. You know, primary's up right now. I'm just trying to find the commonality. Right there on 13. We're going to keep moving it back. So I'm going to flip over to secondary. This secondary. Same input, just fine. So here we are, our last known good on the input, and we're going to work our way back directly into an input on Z401. So we're going to check the output on Z401, and I have replaced this op amp, so I'm not concerned about if it's functioning or not. I've also tested the voltage on this last time I was here. It's also good. On the output of the op amp, which is resistor 416, we're going to resume testing this area. Not too much stronger signal. I've got to change my division. Notice down here division. From primary to secondary. Let's take a look. Let me bring this in again. Here we go. Now we're on secondary. There's no noticeable change. So we're still working here past the amplifier as we expected because primary works fine. Circuit splits out and back into the input. Off of R416, and I don't know exactly how it's designed, but it works, you know, either on primary or secondary. There's nothing about the circuit that changes based on the switch, so I'll just assume that it works. But the other portion also goes to a trace that leads to nowhere, and the third portion comes through C411 that I guess does decoupling of some kind, and then through this resistor R418. Because I get through another 2 components, again, there's nothing that changes based on the switch setting, but since I'm walking it through, my next test point is going to be at the end of R418. So to get this next junction, looks about the same. This is primary, diagnostic. Triggering just right. It's very difficult to do. So with this. Setting it to secondary, there's absolutely no difference whatsoever. So the next junction on this thing feeds into a 555 timer right here, which I've removed, which has no function whatsoever in primary, as shown, and no change in operation on secondary, right? If I go like that. So what does that 555 do if it does nothing, unless it's doing nothing at all? So this is an interesting piece worth looking at. First 2 measurements of the 555 chip, I found that the input voltage is 8 volts DC, which is good. It's using the 8-volt power supply. And I checked the ground off of it against the chassis ground and found that it's 1 ohm resistance, so that's good too. So it looks like that the power going to the 555 and the grounding is acceptable. Now we're going to hook up the oscilloscope and look at the output, so I'm going to tie the oscilloscope onto this now. I'm definitely not seeing any output on the 555, so it could be the 555 or some support circuitry. It's going to have to be further tested. When I inject a waveform directly into the 555, I am seeing something on the output. Let's see what happens when I run the engine with that injected into the 555, if we see any difference on the output. Changing all sorts of timing schemes and parameters and pulses on this 555 is having absolutely no effect on the secondary. It makes me wonder again if this is part of another auxiliary function. It's time to take a look. Sure enough, this 555 again operates in support of an entirely different function. Another dead end. I'll display. And as I change settings, we can see the timing gets skewed. Different function, another dead end. So that's not the trace I'm going to follow. I'll follow the other trace. Working in the other direction, I'm looking at the inputs and outputs of the board right now as it's plugged in. This is pin 3. Pin 3 is what it looks like in primary and secondary as connected right to the back of the board, right? So if I hit the throttle, so we're going to call that one good. What I'd like to see now is changing the coil type. And that's changing the coil type on secondary. Has no effect. And then on primary, no effect. So that's pin 3. Here's pin 7. The same on both settings. Looks the same. Primary. There's secondary. Coil switch, no change. Same thing happened for pin 12. Looks like the outputs are 1, 3, and 7. 1 is common. That leaves 3 and 7. 3 and 7 on the back plane. Move one board over to 300 PLL counter auto sweep. And that board is the most complicated board in the entire system, with the most different ICs and stuff going on. Absolutely wonderful. So yeah, the fun begins. First thing I'm gonna do is try reseating all these bad boys and hope I get lucky. Let's see what happens. I've had to search far and wide to find each individual IC chip found on the circuit board. Thank God for eBay, because that was the easiest way to do it. The only one that was readily available that I was just able to acquire without any issue was obviously this 555 down here, which I also picked up as part of the order. That was going to be replaced as well. The other ones were much more difficult. Before we get started replacing the chips, we're going to have to use the proper hardware. We're going to start with a set of jumper cables here, which are going to be obviously a necessary component for the installation of these ICs to ensure that we don't destroy them through electrostatic discharge. The jumper cable is connected to this garage, which we already know is a ground because we use it to discharge the CRT. That's running up to this table, which is made of fiberglass, but that is connected to my electrostatic discharge band, and that is connected to the thing on my arm. Before we get started, here's all of our ICs that we're going to use as we replace them from this board. We're going to do shotgun replacement. We're not going to stop. Everything must go. I have replaced each and every one of these ICs. None of the originals are remaining. I have checked very carefully to ensure that they have all been installed in the correct direction. And now I'm going to reintroduce this board back into the unit. one?
This one with the broken doof
No,
flop
we'll
piece.
go through the clamps in a later section.
Okay.
Right now we want to see if the logic has been fixed. It can't be the chips, they've all been replaced.
I'll remember how to hook it up. Should be by now.
I know that this one is not even actually used for the test, but just for posterity.
Well, this one, what a mess.
Yeah, I know. We'll get there. Now that I've replaced all the ICs in the unit, we see the primary's been restored since we had the setback. Seems to be working just fine. This is the roster. I'll bring it up to 4 cylinders. Bring the spread back a bit. Not going for direct idle and everything. It's just a demonstration of functionality. There's the roster and there's the primary parade. So that's looking just fine. So the emergency of what happened has now been resolved. We now have working secondary, and this is the roster. We also have parade. It's a lot more difficult to explain what's going on, and unfortunately, at this RPM, it's also harder to see. I'll ask Jason to hit the gas tip for a little bit, so it'll bring it out a bit, and I'll bring it on to parade a little bit more. And we'll switch back to primary.
No, switch back to secondary. And put it so we can see all 4 spark plugs.
And we'll bring it back to, it's going to look bad on the camera though, at this RPM range.
Well,
But this is just a demonstration right now to show that we're starting to get the secondary working on the system. We're going to have to calibrate the ignition for each one of these, 36. And he's going to pull the plug wire right now on number 2. And we see up here an anomaly.
the spark plug, the spark is gone.
And we can see that anomaly is being displayed right now. Interesting that number 2 showing up on the top one. You notice that?
1432 is the firing.
Oh yeah, because the firing order, of course.
1432.
Yeah, correct. Try that again by pulling a no wire. Yeah, pull 3. No, down here.
Maybe a 1342. Plugs are 142.
Okay. So we're gonna come back. We're gonna start calibrating the this over here. It is done again by adjusting these in the back. And Lord knows, after 40 years, they can use calibration. So we're gonna do that now until we have more of